third pole is 1 plus j omega upon 10. It is decaying by minus 20 dB per decade. Second pole is decaying by minus 40 dB per decade. This is a minus 40 dB per decade. Plus, this is a decaying once again. How much? Minus 20 dB per decade. So my resultant becomes, the magnitude plot is minus 60 dB per decade. This is my plot. And the range is between, see, this is a 10. See, the Bode plot. This is a Bode plot. This the value is 0.5, 0.1, 10, 100, 1000 up to 10,000. We are taking the value between the 1 to 10,000. So, first of all, the magnitude plot, we are taking the value is minus 2, is minus 60 per decade. But it is from minus, the range is between from 10 is less than or equal to omega is less than or equal to how much? Infinity. This is my magnitude plot. For the phase angle. So we know what to find the phase angle. What is the formula for the phase angle? Theta is equals to tan inverse of imaginary part upon real part. So for that, first we have to take in the phase angle. For phase angle, first of all we have to take in the value of omega, then 1 upon j omega means one pole is present at the origin, the value is 0, means the resultant is how much? Minus 90 dB per decade. This is a, then second pole is 1 upon, means minus tan inverse of. Why minus tan inverse? The value is given, that is in the denominator. The value is not in the numerator. If the value is present at the numerator, so we have to take the plus value. But the value is present at the denominator. It is a pole. That's why it is a minus tan inverse of omega by 0.5. This is my first value. Second value is minus tan inverse of omega by 10. And last column is the resultant, means the addition of all these. The value of the omega we have to taken by your own. It's not compulsion. The value is taken between that this is 1, this is 2, so we have to take on the 2. No, that is not like that. So the value of the omega in Bode plot, you can observe this is from 0.5, 1, 10, 100, 1000, 10,000. So we take the value from 0.1 to 10,000. So, but the value should not be greater, means if the value, first value we have taken 0.1 and second value is taken 1, third value is taken is 100. So the viewer phase will not be in the perfect way. So that's why we have to take the value which is nearest. So first value is my 0.1 minus tan inverse of 0.1 upon 0.5 minus tan inverse of 0.1 upon 10, and then we have to find the resultant. See, the calculation degrees shift tan inverse 0.1 upon 0.5. So what is the value we are getting? It is a 11.30 first value. My second value is, here we have to just change, then value is 0.5729, means it is value is in minus. So we have to find the resultant. So resultant is, my first is value pole is minus 90 minus 11.30 minus 0.5729. This is my values. So what is the value first come is 108.79. This is my first value. So we have to, but the magnitude, but we have to write the resultant, it is in the plus. So my second value is, I take the value is, suppose my 0.3 is my second value. It is minus 90 degree. Again take the values of tan inverse. How much? It is a 0.3 by 0.5. I'm getting minus 30.96. Just change it, the value. It is a minus 1.7183. Again, once again take the value resultant, minus 90, minus 30.96, minus 1.7183. Likewise, we have find all the values. Now we have to move towards the Bode plot. See, we have to take the line. It's my zero line. Suppose it is light. Keep it in mind. The value is in the faint line. This is a 20 dB per decade. This is minus 40 dB per decade. And this is minus 60 dB per decade. So the value of K we have got, the value is nothing but how much? It is a 26.02, means the value should be the value is at a 26.02, means the value is here 26.02. This is my 26.02. So sorry, this is a 20 log 10 to the base of K, that is equal nothing but 26.02. So now we have to first of all draw the line. First one line we are drawing. Suppose I will draw here the value we have taken, that is a first of all see, it is a 0 dB per decade. First of all draw the faint lines, which is a passing through the zero line, means it is minus 20 dB, then minus 40 dB, then sorry, and it is a minus 60 dB. First of all draw these faint lines. See, in our example we are getting the poles. First pole is decaying by how much? Minus 20 dB per decade. But the range is how much? From 0 to 0.5. So our plot will be, it is a 0 to 0.5. This is 0. It is a parallel. So it is a 0.5. Then our second value, which is a decaying by how much? Minus 40 dB per decade. This is my minus 40 dB per decade. So take the value which is a parallel, exactly parallel. So it is a parallel. It is a 0.2. This is 0. This is this lines 0.3. This is 0.4. 0.5, this is 0.6, 0.7, 0.8, 0.9, and this is 1. So my value is minus 20 dB per decade up to where? 0.5. So up to 0.5 draw the dark line. It is my 0.5 first value. So draw exactly parallel line. This is the second pole is how much? Minus 40 dB per decade. So go here. See, and this is a minus 40 dB per decade up to where? Up to 10. So my value after 10 is here. This is a 10. The third one is how much? The value is from the decaying from the 10 to infinity. That's why my is decaying by minus 60 dB per decade. So see parallel line which is a 60 dB per decade. Draw exactly parallel line which is parallel to the minus 60 dB per decade. This is my minus 60 dB per decade. So this is a complete body plot, but here we have completed only up to the magnitude part. So now we have to find the phase angle. For the phase angle we have to, suppose here we have to consider it is a, suppose, so my first pole is minus 90, second one is minus 120, this is a minus 150, this is a minus 180, this is a minus 210, This is my 240. This is my 270. See, first of all, the value of the magnitude, first magnitude is 101. It is my resultant. So it is value of 101.87. Means here we have to find where is 101. You see, this is the line. It is in the gap between how much? Minus 19 to minus 15. Means it is a 30 degree. Means 0. This is a 5, 10, then 20, 25 and 30. Means 10, 20 and 30. See, so value is in between the 101. Means it is a 95, it is a 100, and it is a 100 point something. Here we get the 100.01. This is my first plot at the omega is equals to 0.1. Second value is from my, it is omega, the value of the omega is 0.3. It is a 122.67. So here is 1.22. It is a 120. Means exactly below the 120, the value will be 122.67. Yes or no? So here 0.3. Where is 0.3? This is my 0.3. This is the value is 122.67. My third value is 0.5. Value is 137.8. Where is my one? This is a 120, 120, 125, 130. Means here is my 130. So we have to find 135. 135 and 137. 137 means the value becomes here. It is a 137. The value is at the 0.5. 0.5. It is a, see, this is a 0.5. This is a 120, 130, 130.5. Then the next value is my 159.1 at the 1. So 1 we have to getting the angle is how much? Resulted is 187. This means it is cutting this line and we are getting here some 1. It is a 187.13. My second value is for the 4. Means it is a 1. The value is 2. This is a 3. This is a 4. This is a 5, 6, 7, 8, 9 and this is 10. So now we have to find value is 232. Sorry, for the value for the 3 we have getting the value is 187. 187 means, sorry, this is my 187 for the value for the 6. Its value is 187.5. So this is my 187.5. But where is the value for the all the values we have find now? The values in the value that is given for the phase angle. That is the value only we have to taken. So now we have to connect it in the proper way. Up to this point is everything is okay, I think. So now the main important part is remaining. So we have to know what we have to find. We have to find now what is the gain margin, what is the phase margin, what is omega GC and omega PC. The value which cuts the 180 degree Celsius, 180 degree, it is called as the gain margin. Means omega GC. So gain crossover, sorry. This is a 180 line. This is my 180 line. So my line is cutting over here. This is nothing but what? Omega GC. So what is the value of the omega GC now? This is a C. This is a 0.1, 0.2, 0.3, 0.4, 0.5. Likewise, the value is gonna be increases. This is the value is omega GC means 2.1 and 2. Means omega GC is equals to 2.2. So now we have to find the omega PC, the line which crosses the 0 degree Celsius. Sorry, 0 degree. Here we are cutting the line which is a 0 degree. So this is nothing but omega PC. So what is the value for the omega PC? Value for the omega PC, the line is extend below up to here. We getting 0.5 and 0.6 omega PC is equals to 0.6. So now we have to find the omega PC. Omega PC and omega GC we have to already find. Now we have to find the phase margin. So for the phase margin, the line we have to extend here. It is a line which is crosses the 180 degree. It is my first line, and the line which covers here, it's a 174. Means see, now we have to find the resultant. Phi means for the value for the phase margin, PM is equals to 180 plus phi. Minus 180 plus pi. This is my minus 180, and this is the value is complete for 174. This is the 174. So my phase margin is minus 6. So we have to write here what is the value of the omega GC, what is the value of the omega PC, what is the value of the gauge margin, what is the value of the phase margin. So my phase margin is minus 66 degree. My omega PC, the value for the omega PC is 0.6 and omega GC is 2.2. This is the complete solution for the Bode plot. Thank you.